Good morning again to everyone. My name is Victor Anaya. I'm coming from Information Catalyst. As Stefan was saying, I am going to present the technical architecture. The goal of the presentation is not to push to you a lot of, technology concepts, but to give a bit of the ground of also the philosophy that we try to take into this project. And then this will be introductory to the presentations where you will see actual demos and software working. So first of all, we are grounded in a reality, in a technological reality. Manufacturing companies, companies in Europe are no longer, only manual driven. We know that in Europe there are a lot of companies that they don't only have machines but automatized lines, that they are starting to have in smaller ones robots, in medium ones they have quite a lot of robotics, and that they are already taking a lot of information coming from dozens of sensors. This is an actual reality. So one of the problems that knowledge is trying to address is how to make sense of that reality, how to make sense and support the strategy of a company with all that data, applying AI algorithms. We know also that this range of machines and sensors are being produced by different kind of companies, by different manufacturers of these PLCs and sensors. So there is a heterogeneity and a complexity integrating the different industrial communication protocols. And you will see how we try to address this kind of problem. And we also know that now with the AI wave, as we call, it's difficult for manufacturing companies to cope with the advantages. Because at the end of the day, AI is not the core of the manufacturing business. The core is to achieve a competitive advantage through the AI. But the problem is that now, every 3 or 6 months, there are new technologies coming. It seems that you have spent your money in a new AI technique, and it seems that it's going to be obsolete already when you start to deploy it. And it's also a problem that we are trying to address, how to address to the concerns that the manufacturing companies have regarding on having enough AI talent on their own companies, how not to waste their funds when investing in AI technologies, how to manage the data if the data is going to be, as Stefan was saying, in a black box and I lose control of that information. Stefan mentioned also Industry 5.0. What's going to happen if we automatize everything? Are we going to lose jobs? How is going to be the human impacted? This is something that in the project we have in mind. The techniques that you will see are only human in the loop techniques, meaning that, as Stefan mentioned, it's the collaboration between AI and a human. And we are also thinking specifically in addressing the platform to small and medium European companies, meaning that we know that the solution shouldn't be super complex and it should be addressing the usage by medium-sized companies. With all that grounding, we started to consider different sources of concerns and requirements. We considered our industrial pilots. We considered the technical expertise of the partners in the companies and the events that we were attending. We went also to do analysis of the market, and then we came with this architecture that is our generic knowledge architecture. Is composed of 5 layers. The central ones are the most specific ones, where you can see that we have components addressing the gathering and the feedback of information. When we capture and homogenize that information, we push it into the analytics and AI layer that you will see specific presentation on it, how we tackle with those techniques. And then the point is how we interact with humans, that is in the very top. You will see that we have 3 specific components: a digital twin, a human AI collaboration tool, a DSS, and then we have specific components to share information, because at this stage it's important to not start from scratch a given solution, but to consider information that is and solutions that are coming and that are existing. We didn't define the architecture from scratch, meaning that we have considered good standards, good well-known initiatives such as RAMI that for sure that some of you know. We also consider relevant industrial protocols so that the platform can already out of the box connect with a whole range of manufacturing devices. And also we know that we are not going to change the whole technical infrastructure in a company. So we propose and we can run existing AI solutions. We also generate AI solutions that can be run in different platforms. So our role here is to play along with existing initiatives. So going quickly through the layers, you will see that in terms of the data, the pains that we are trying to address is that, as I mentioned, there is that kind of heterogeneity and distributed devices. We know that the algorithms should be run also in different powerful capacity devices, meaning there are, you know, servers that are very powerful, but edge devices that should be able to run also small and quick algorithms. And for doing that, we have the data collection platform and the edge to cloud deployable infrastructure that you will see how it's working, how the different layers can synchronize data to keep up to date also in a supply chain. Also, it's a big issue, the concerns of how the data that is gathered by the software should have enough quality. We have specific components addressing that. What happens if the data is not there or if it's complex to gather the data? Then instead of running expensive experiments, we provide the digital twin with specific modules for generating synthetic data. In the case of AI, we are providing cognitive service, so we have a set of algorithms that are able to detect anomalies from images captured in the shop floor. We are providing mechanisms to make easier to train and retrain algorithms. What else we have? A specific component to recommend which kind of infrastructure is optimal, so you don't waste time and you don't waste money over scaling your infrastructure. In terms of the human AI interaction that is related with the previous slide, our philosophy is to leverage the human, not take on it. And for doing that, we have specific modules that you will see in one of these presentations that it will talk about how we get him or her in the loop, how we gather his knowledge. That knowledge can be used for accepting the value of the algorithm, but also for labeling the algorithm, to make the algorithm to train quicker, because you are providing your set of rules, your knowledge to the algorithm. And we are also providing a DSS. You will see this in extension, and a digital twin that is able to play what-if scenarios to accelerate the way of that the human in the manufacturing field can understand what happens if this machine fails, what happens if I have less or more resources. In terms of the problem of finance sharing, we know that at the end there are so many initiatives that at the end it's difficult to know what do you have to use. There are 3, 4 solutions. What should I pick for trying to help the manufacturing user? We have a marketplace that is able to offer the algorithms that are runnable in our platform, that are not necessary to be deployed in our platform, but that are runnable on top of it. We have a semantic repository that is able to allow the user to search for the the repository using different kind of dimensions, such as type of problem, not only give me that unsupervised specific technique, but using the wording of the manufacturing people. That marketplace is supported by the blockchain technology, meaning that is robust and secure, and that the solutions that are offered can be retrained in the platform, meaning that you can start not from scratch. You can take, for example, an algorithm that is able to detect already anomalies and fine-tune. That means to adapt so that you shortcut the time that you have to spend to deploy it in your company. And finally, we have components that are able to secure that that your data is not going to be hacked, and that if you want to upscale or downscale your solution, it's going to be transparent, meaning that if for any need you start to add in the supply chain more power capacity, we have a deploy that is able to deploy the components without a lot of hassle.